Welcome to Astronomy Daily, the podcast where we chat about the coolest space and astronomy news we can source. I'm Anna, and with me is my co-host Avery. Hey Avery, it's January 8th, 2026. How's your week going?
Hey Anna, and hello to all our listeners. It's been fantastic. Clear nights for some stargazing. We've got a stellar lineup today. Mysteries solved on a famous star, a decades-long supernova video, a census of nearby stars for life, lunar events to watch, a dramatic but low-risk orbital scenario, and fresh insights on asteroid mining. Plenty to unpack. Let's get started.
Leading off with big news from Orion, astronomers have finally cracked Betelgeuse's biggest mystery, the cause of its weird brightness swings and that dramatic great dimming back in 2020.
Yeah, this red supergiant, one of the brightest stars in the sky and about 650 light years away, has been puzzling folks forever with its pulsations. It has a short 400-day cycle from internal throbbing, but there's this longer 2100-day variation that stumped everyone. Theories range from giant convection cells to dust clouds or even a companion star.
Turns out it is a hidden companion. Researchers from the Center for Astrophysics at Harvard and Smithsonian, led by Andrea Dupree, used nearly 8 years of Hubble data plus ground telescopes to spot direct evidence. The companion, playfully called Siwirha, orbits every 6 years or so, plowing through Betelgeuse's massive extended atmosphere, like a boat cutting through water, leaving a dense wake of gas.
That wake disrupts the star's light and spectrum, causing the dimming and patterns we see. Dupree described it perfectly. It's a bit like a boat moving through water. The companion star creates a ripple effect in Betelgeuse's atmosphere that we can actually see in the data. They caught the wake forming right after the companion passes in front.
This explains the 2020 sneeze, too. Dust and gas from that interaction. Huge implications. It shows how companions can reshape massive stars' evolution, mass loss, and eventual supernovae. Betelgeuse is eclipsing Siwirha right now, but they'll watch for it emerging in 2027.
Front row seat to a star's dramatic life. Love it.
Next, NASA dropped an incredible video that's literally decades in the making, a time-lapse of Kepler's supernova remnant from Chandra X-ray Observatory data.
This is the remnant from the supernova spotted by Johannes Kepler in 1604, a Type 1a explosion from a white dwarf that blew up after gaining too much mass, maybe from a companion or merger. It's about 17,000 light years away, and Chandra's been watching since 2000.
The video combines observations from 2000, 2004, 2006, 2014, and even 2025, over 25 years. It shows this neon blue X-ray ring expanding like a balloon, overlaid on optical light. The bottom side blasts out faster at 13.8 million miles per hour, while the top lags at 4 million miles per hour because it hits denser gas.
Chandra glows in blue from million-degree material, and the rim measurements tell us about the explosion's power and surroundings. It's the longest-spanning Chandra video ever, showing how the remnant crashes into space stuff, hurling elements for new stars and planets.
Mind-blowing to see cosmic history unfold frame by frame.
Shifting closer to home, a new all-sky census of over 2,100 K-dwarfs within about 130 light-years reveals some prime real estate for potential life-bearing planets.
K-dwarfs are cooler, fainter orange stars, twice as common as sun-like G-dwarfs nearby, and they live way longer, giving planets stable radiation for billions more years, perfect for life to evolve slowly.
The team used high-res spectrometers on telescopes in Chile and Arizona for full sky coverage. They measured temperatures, ages, spin rates, magnetic activity, all key for habitability, since flaring stars can strip atmospheres.
This spectroscopic recon is a goldmine dataset for future exoplanet hunts and even interstellar travel planning. Presented just this week at the AAS meeting, it's foundational for decades.
Makes you wonder how many Earth-likes are chilling around these steady stars.
For skywatchers, especially down south, 2026 has some lunar treats: a red moon from a total eclipse, a blue moon, and a Christmas Eve supermoon.
The total lunar eclipse on March 3rd evening will turn the moon coppery red as Earth's atmosphere bends sunset light onto it. Totality's best from the southern hemisphere, Australia, New Zealand, lasting about an hour, visible even in cities' naked eye.
Then a blue moon on May 31st, the second full moon in a month, a calendar quirk every couple years. And December 24th supermoon, full moon at perigee, looking bigger and brighter, perfect illusion at moonrise.
No equipment needed, safe to watch. Mark those calendars for some magical nights.
Now, a headline grabber. Could a passing star fling Earth into deep space, destabilizing our orbit faster than thought?
This comes from simulations by Nathan Kaib and Sean Raymond, factoring in galactic flybys, stars passing within 100 AU at slow speeds. Normally, solar system models assume isolation, but reality includes these encounters.
Mercury's the weak link. A flyby could make its orbit more eccentric, leading to crashes or tugs that cascade outward. Maybe Venus or Mars nudging Earth toward Jupiter for a slingshot ejection.
Probability? About 0.2% chance over the next 5 billion years for Earth ejection or collision. Tiny, but higher than old estimates. Pluto's risk is 4 to 5%. Based on Gaia data and A-archive paper, real science, but the article amps up the drama with hidden threat vibes.
Comforting to know it's super rare. Our orbit's stable for eons.
Last up, is asteroid mining actually feasible? New chemistry data from meteorites offers sobering but insightful answers.
Researchers analyzed carbonaceous chondrites, proxies for C-type asteroids, measuring 46 elements. These primitive rocks mix metals, silicates, water-bearing stuff, but impacts create breccias and regolith, making separation tough in low gravity.
Some groups show enriched titanium or rare earths, but overall depleted in easy metals like copper. Water alteration oxidizes things, complicating extraction. Led by Josep Trigo Rodriguez and team, it suggests mining's hard for bulk profit, better for targeted water or in-space manufacturing.
Focus on sample returns, like OSIRIS-REx, to pick winners. Feasible eventually with tech advances, but not a quick space gold rush.
Realistic view. Space resources for exploration, not Earth riches.
Whew, from stellar companions to lunar lights and cosmic risks. What a ride today.
The universe never runs out of stories. Thanks for joining us on Astronomy Daily. We appreciate every listen.
Subscribe, share, and we'll catch you tomorrow with more.
Keep looking up.
Clear skies.